So, good day again, students, and welcome to the homework concerning techniques to extract the energy from a biofuel and to make use of that energy for industrial purposes. What the homework is about is to teach you how to estimate the needs of fuel for a certain process. And it is also to prepare you for the final examination, because that will deal with the system aspects and the whole supply chain. To have a good idea of the whole system, you should read section 030002 in the BusyPlan Handbook. As you will understand from that, there are several unit operations involved in the handling, and it is obvious that the costs for all these steps must finally be paid by the end user, since all the costs will accumulate into the price of the final product. And the total costs will depend on the amounts of material handled, so you have to have an idea of the amounts involved. Let us look at some simple examples. First, consider aluminium can recycling using wood chips. The input data are given in the slide. The first thing you have to do is to calculate the real heating value for the fuel. Then the thermal power, the energy flow in megajoules per second, is calculated. Dividing the desired flow of energy with the heating value now yields the fuel flow in kilograms per second. And then use the bulk density to obtain the volume. You now understand why you previously learned how to compute the energy density of a fuel. As you see from the slide, wood pellets save transports, but on the other hand they have a higher price. Sometimes may the saving in transports and the smaller storages be enough to pay for the more expensive fuel, sometimes not. As said in the previous nugget, some processes may be best suited to use gaseous biofuel, and generally will processes have efficiencies less than 100%. So let us look at a slightly more complicated case. The input data are given in the slide. You will notice that the process runs 24 hours per day and 7 days per week. And here we have two processes, the final process and the gasification process, connected in series, and they both have efficiencies that are less than 100%. Again, the first step is to compute the real heating value in megajoules per kilo, and also to figure out the energy demand expressed in megajoules per second. But in this case, the energy demand must be increased due to the efficiency. This is done by dividing the net energy flow by the efficiency. The gasifier need of input fuel is treated the same way. The example serves to show how a specific process is connected to a societal aspect, like the waste handling system, via the fuel properties. But then you may just as well look at it from the other end. You can start from the biomass end, like with the number of cattle at a farm, and then you can estimate how big a process could be run by the fuel produced from this group of cattle. To do this example, I suggest you use the BusyPlan spreadsheet. Remember that the spreadsheet is protected, and in some cases you may have to unprotect it using the password BusyPlan. What you shall finally do is to perform a similar calculation as the previous examples. The data are given in this slide.